All right, so it is 6:20, and I will continue the next segment of the class. Thank you, Camille, for doing the game through the console. So we wanted to show today how we can like make various games, not just through PyGame like we've been teaching for the past two games. So Camille gave a good example with rock, paper, scissors, which may have been like, for some of you guys like a refresher through, basic code. Now we're gonna go back to our previous curriculum that we had with PyGame. And today, I know Camille did say I was going to do tic-tac-toe. Instead, there's been a change of plans. I know last class we also said we were going to do hangman. Instead, we're going to do something maybe a little more. Um, it depends. I want to introduce uh, you guys into gridding when it comes to these like display uh, things in Pygame. And I thought Snake would be a great example for this. So I'm going to share my pie chart really quickly. And just want to make sure, Cam, can you let me know if you can see this? Or could someone just let me know? All right, great. So let's get started and import some modules, right? In this case, we're going to work with PyGame, obviously. So we're going to import PyGame. And another thing that we want to import is going to be the random function. Or the module, sorry. The reason we want to import random is because if you guys have ever played Snake before, let me actually share my screen and put you on the Snake game. One second. Okay. If I do, I play this. This is what Snake is. And I want you guys to realize a few things when it comes to this, right? As you can see, there are multiple squares here, right? This is what we call gridding. Okay, I'm going to go more in depth in this when we do this later. But each of this is what we call a grid. Okay, and obviously, I do this. I am moving my snake around. But every time I eat this apple, it randomly goes to a different place on the screen, which is why we want to import the module random. So this is Snake, by the way, if anyone does not know the game. This is exactly what we're going to program today. Maybe a lot simpler, though, than the Google version. So, all right. So after importing our modules, we are going to start with some basic variables that we've been going with. So we're going to go with screen width, right? Your screen width could be anything you want, right? In this case, I want to go with I would say a 24 by 24 grid, like those boxes that you saw. So I'm going to do 480. And I'm going to show you how I'm going to get like the 24 number that I just said. Okay, and then the same thing with height. I want that to be 480 as well. Okay, now grid size is what I wanted. Right, we're going to say grid size is equal to 20. So if you do 480 divided by 20, you're going to get 24. So that is the amount of grids that we're going to get because of this, the screen width divided by the grid size. Although we're going to need, the computer's not going to know what I'm going to do with the grid size, so I'm going to have to cut this down into more variables. Okay, so I'm going to cut this down to grid width and set that equal to screen width divided by grid size. Okay, so now the grid width is based off of this, which is going to be 24 pixels, and then the same thing with the grid height. So we're going to do grid height is equal to screen underscore height over grid size. Okay. All right, so these are just some variables that we have. Okay. Now, another thing I want to mention is I'm going to share my uh, screen, my entire screen. Actually, wait. I'm gonna go to Paint really quickly and just share Paint. There's gonna be a lot of sharing and unsharing when it comes to this. Okay. So I'm gonna draw out my grids really quickly. So this is basically gridding. In this case, you see that I have a 3 by, if I keep drawing this, probably gonna go out to like uh 7, I would say. Yeah, so this is I think 7, 1, 2, 3, 4, 5, 6, 7. Okay, so this is a 7 by 3 grid. Okay. In my case, when I eventually draw out the program, it's going to be a 24 by 24 of these, right? So we're gonna have like, times 8 on the top here, and then we're gonna have like whatever, a lot more down here, right? We're gonna have like 17 more onto like the vertical axis, and we're gonna have 21 more on like the horizontal axis. So that is basically gridding. We're just designing these grids so that we know where we can eventually put out our apples that we're going to draw, or these things that we're going to eat soon. This is exactly what we're drawing out. So we know where we're going to randomize where the food is going to go, or where the actual snake is going to go if we're going to go like this, right? We don't want the snake going in a diagonal pattern. We want it to go through and follow this grid pattern, right? Which is why gridding is very important when it comes to snake. Okay. Now, my next line of code is going to be, oh, that's interesting. Okay. My next line of code is going to be sort of weird if you guys don't know axes, or axes, I should say. So, my thing is, can you see my thing is flashing in and out on my screen? Hold on. 1 second. I'm just gonna share my screen once more. Uh, Paint. Okay. Okay. So my next line of code is going to be a little confusing for some that do not know what I'm about to, does not know like basic axes. We need to define what we call we have to define sort of like these sets for our direction, right? So our direction is going to be based off of I think it's sort of the opposite for vertical, and then it's the same for um horizontal. Okay. So axes run on a x comma y formation, right? So x being your horizontal and then y being your vertical. So when it comes to PyGame, we're running off of a grid that cuts off all of the other quartiles, such as um, like this one, this one, this one. It's working on a single quartile, right? So 1/4 of an entire grid. If you remember last class when we were working on moving our rectangle around, it may seem a little odd when up was equal to a negative value and down was equal to a positive value. In math, that's not how it is. Up tends to be a positive value and down tends to be a negative. Although in this case, when it comes to positioning, it's the opposite. A PyGame is just like that, right? So we need to define our up, our down, our left, and our right variables based on PyGame, or PyGame directions. So we're gonna go off with the basic ones and do left, right. Okay. So left is going to be, we're going to move it about a pixel each, right? So if we're just working with 1 pixel to the left, we're doing 1 pixel to the left, so that's -1, right? If we're moving to the left, it's going back 1, comma 0, because we're not moving up or down, right? Y is up and down, X is left, right. Now it's the same thing with right, although it's going to go the opposite direction, so it's going to be a +1, right? So if you worked with basic math before, this is going to be the same thing. Now, up and down is going to be the opposite of this. So we can work with our x-axis being zeros because those aren't moving. We're not moving like left, right. Now our y value is changing, but like I said, this is going to be a little weird. Up is going to be -1 and down is going to be 1. This is just how it is. We're just going to have to work through this and deal with all this code, right? So I'm going to go ahead and delete this, and we're going to set these values in to our actual code. All right. So we need to define, we're just going to call them up into our little sets here and do that. Same thing with down, left, and then right. And so we're just sort of declaring our values for these directions. 1, 0, and then right equal to 1, 0. All right. Now, we're basically done when it comes to these general directions, and this is all public. All of this code is public. This is going to be accessed throughout the entire file. We're going to move into something a little more complicated and define functions and actually create classes. Okay, so we never officially went through creating classes, so we're just going to go through a basic run through when it comes to these, right? We want to create a class, and we're going to call this class Snake because that's the game that we're going to make. In Snake, we want to define specific functions based on, the snake itself. So what we want to do is we want to sort of define the initial values of our snake. And to do that, we're going to define a value called underscore in itself. This is how we're going to define our individual values. Self is an automatic value that will be plugged into majority of these functions. Okay. So let's go ahead and design self to have a length of 1. Okay. In this case, we're just going to go with the basic value. Next, we want to create a set that contains a tuple with 2 values in it that has its position. So it's x value and then it's y value, right? So we're going to go ahead and define our initial position and set this equal to. This is going to set us right in the middle of our grid because we're setting this, we're just going to have our default value set equal to the beginning of the game to be the middle of the grid. I don't know if that makes sense. So let's say your snake dies and you lose. It's going to automatically put you back to the middle of the grid so you can restart your game over. Right? That's basically what I'm trying to say. Okay. So we're going to do screen width, and we're going to divide that by 2. Okay. So that's how we get it right in like the middle because we're halving it. So it's going to be half of the width. Right. And then we're going to do the same thing with the height so we can get that same position. Okay. So do comma, and then we're going to do screen underscore height, and then we're going to divide that by 2. And now we have our position set automatically to the middle of our screen. Next, we want our direction to be our initial direction to either be up, down, left, or right. We can make it so like in our Google game, we can just have it sit still until a user input is made, and then it would move in that specific direction. But let's make this a little harder on the user. So we're gonna do a random dot choice sort of. We're gonna do random dot choice, and random dot choice is a function that picks out a random variable or value, value within a set. So we have to create a set. And we're going to make this harder for the user so it can either randomly go up, left, down, or to the right. So let's declare our values as well that we have here. And let's create a color for our snake, just something little that doesn't hurt. So we kind of have to do color as well, so we don't mix up the background color with our actual snake color. So I have a list of values just set up um, here. Let me actually just go ahead and pick out a color really quickly. Um, Let me just go to HTML color codes. I am just going to pick out a color that looks a little nice. Let's go with sort of like a purplish color. So I am going to set this color equal to 160, comma 55, comma 205. Okay. So that's going to be the color of our snake. Now, we also want to set a initial score value, right? So this is going to be 0. We're not going to start off with uh, anything more than 0 because that's our initial value. Next, we want to define, we want to actually be able to move our snake. So we're going to define a turn function. Okay. We're going to either turn to the left, to the right, or whatnot. This is going to get a little complicated, and so you're just gonna have to follow along. Uh, hold on, I think I'm lagging a little bit. Okay, so it's gonna get a little complicated for some, like from here on out. A lot of math is going to get into this, maybe a little bit more advanced math. So I'm just gonna try to explain it to the best of my ability. But this is kind of how PyGame just functions, anyways. A lot of this is based on math too, right? So we want to return we want to be able, this is a method that we want to sort of, how do I put this in the best way possible. It's hard to explain, although I'm just going to start writing out the code and maybe I'll be able to explain it as I do this. um Comma 1. So I am going to initialize another variable in our turn function. It's going to be our point function. This is sort of going to be the point that we're at based on our grids. So you see I have an array list here that I initialized here. Point is going to be a set that I am initializing as a parameter in our method. Our parameter is like these, so self is our parameter here. It's like our values that are specific to these. And we will set this equal to the direction that we have, right? If, for example, what this is doing is checking if our direction is the same as our event, like our soon to be input. So if we're moving our snake around and we're going up, right? If our snake touches like itself, like it touches its tail, you lose the game, right? That's how snake works. So if I am moving up and let's say I have a length of 5, and for some reason I hit the down arrow, the snake is not going to go inside of itself, right? So this is what we're doing to sort of limit that. So if that ever happens, we're going to return nothing. So basically saying that if that happens, we're just going to do nothing, right? And then other than that, if our direction doesn't do that, we're going to set this equal to the point. And the point is eventually going to be where we turn to. Okay. So that was the best way I could explain that. Now, to actually get to that, I should define another function. Because when it comes to snake, I explained that if the head of the snake touches the tail of the snake, or if the head of the snake touches like an apple, we need to know where the head is, right? So we're going to define a function called getHeadPosition. So we can actually know where the snake is on the grid in case we ever need to see it interact with anything else. What we're going to do is we're just going to return our self position value here, right? This is where we defined our positions before. So we're just getting that value wherever that snake is in case we need it further on. Okay. Right now, we're just defining a bunch of functions within our snake function. This is just the snake itself, right? We're not touching the food yet. That's going to be another class that we're going to make later. Okay. So let's actually get this snake to move. Okay. We're going to call the head of the snake sort of, we're just going to call this, let's call this head. Okay. Just a very simple this. We're going to call this self.get underscore head position. Actually, let's do head pos. Next, we're going to do x comma y is equal to self-direction. Okay, self-direction we have here as like one of these choices, but this is also eventually going to tell us where we're going to move depending on our like x and y values that we have defined here. So self-direction is randomly chosen here as our initial thing, but to actually move, we have like the tuples here, so we're assigning it to an xy value when we actually need to be able to move soon. Okay. Now, what we want to do is we want to create a new position value, right? So we're just going to call this new. To actually move, we're going to eventually need new positions. Okay. So in that case, let's start coding that so we can actually get the snake to move wherever you need to. We're going to do head position and its initial value, right? Plus the x, we're going to do x times the grid size, right? And we're going to mod that with screen width. I'm going to show you how this even works. So like I said, this is going to require a lot of math, right? Next, we're going to do a head position, the next one, plus y times grid size. And then we're going to mod this with screen height. Okay. So what this just did is we're changing our positions through this with a new xy sort of value. What this is doing is this is finding our position of the x value of like our head position, and then we are working towards we're multiplying our x value that we have here by the grid size, and then we're just going to mod it with screen width. So let's say our value is so let's say our value is 2, right? Our position is 2, for example. We multiply it with the grid size, which is 20, so that's going to be 40, and we mod this with screen width. That's not going to move anywhere because we're stuck in the corner practically if we're doing that. So there's going to be no point of actually moving it anywhere. So our value is going to remain the same. And then same thing with the height. It's going to be the same thing, although it's going to be in like a different direction, more of like a vertical, more on the vertical axis, right? So now we're going to need a if statement. So we're going to do the length of self position, right? So we're going to get the length of the set for length positions. If it is greater than 2 and new in self dot position is this. Okay. So this is a new line of code that's sort of going to be debugging the rest of it's sort of like a debugger. And what this is doing is it's going to reset the entire snake itself if the position is if this is supposed to like reset the game if there's ever like a error with the position in the set, right? So if the set sort of like the position of it ever there's more values than there should be, then it's just going to reset the game, right? That's sort of like a debugging code. And else if anything happens or everything else happens, right? So if the game actually works, we're going to insert a new value. So 0 comma new are new values, and then if len dot self positions is greater than self.length, then we're going to reset, or we're not going to reset. We're going to remove or pop one of the values in the set for position. Okay, so that is our move function. Yes, this is sort of complicated. If you don't know like the mathematics towards it, it's sort of hard to explain it in a more of a lower level compared to this is a big step up from rock paper scissors and then all of a sudden go into like these games where a lot of math is required, right? um so next we're going to define our reset, right? So we had a reset function here, but I'm surprised I don't have an error here because it hasn't actually been defined yet. So we're going to reset everything here. So this is just going to be the same values as our initialized snake that we have. So I can sort of just copy and paste all of this, although I don't need to change the color of the snake because the color of the snake doesn't change anywhere. Okay. Next, we're going to have to define a draw function. Self comma surface. I don't have defined at the moment. Surface is just going to be the name of the window, right? So next, we're going to do for p in self dot position. So this is going to check all of the positions that the snake is in, right? We're going to call the rectangle rect. So rect equals PyGame dot rectangle. What we're doing right now is we're drawing the snake. So if let's say the snake eats an apple, then we need to actually draw another portion of the snake, right? So that's what we're doing right now. We're going to draw that. Just give me 1 second. Okay. So rect equals pygame dot rect. Surface pygame dot rect. Oh, we need to define the dimensions. So, or the positions. So we're going to do P1 and then P0, P1. So that's just getting the X and Y values from the positions list, right? And then we're just going to set this to another um, tuple grid size. Grid size. Okay, so that's just our XY values of that rect. Then we're going to do pygame dot, let me call this. Our meet is going to end in 10 minutes. There is a lot more. So I think what I'm going to do is we might end the class after defining our snake function because creating the food class is going to take a long time as well with a lot of elaboration on what I did with the math. And there's going to be a whole section for debugging. And I don't want to have you guys sit here for more than like an hour and a half, right? So I think when I'm done with the snake class, we're going to end the class. And then next class, I'll start off from where I finished and move on with the rest of the code, which may take up a little bit. And then Cam will do another game. He should have, I think, maybe Hangman ready by then. And then we're just going to move on by there. Right. So let me just finish up the snake class. So we are going to actually draw the rectangles or draw the snake itself on the surface with the color that we're given on those dimensions, right? Next, we want to create another rectangle on the same surface with, let's say, the colors being, we'll just pick out 93, 216, 288, or 228. And then we're going to do it on the same dimensions. And we want it to be with in that position. Okay. Next, we want to when it comes to the movement, we want to actually have the keys handled, right? So For the event that this is sort of the aspect of like pressing a key, and then we're gonna like change our direction. So that's what this class is going to be. So for event in PyGame dot event dot get, we went over in our initial PyGame lessons. This is how we sort of close out of the game when we need to. PyGame dot quit, and then PyGame dot quit. Okay. Next, we need to, outside of the for loop, we are going to do elif, or inside the for loop, I should say, sorry. Elif the event dot type is equal to pygame dot key down. Okay. Okay, so what we did here is, I know this is like the more familiar aspect when we went over in the previous classes. This is just a basic thing. If we quit out on like the X button here, the reason we're putting it in here is because we're already calling out the for loop, or we were going to call out the for loop for in case like a button was pressed here. It's the same thing. If the event that like this X button is X is clicked, then we would close out of like the game. It's sort of the same thing here. In case like, a key was pressed, then we have to do something. So we're just saving more time when we're calling it here. Right. So now let's go on with the key portion. So if the key is pressed, if the key that is pressed is the up arrow key, we want to turn our snake up, right? And this is going to be the same thing for down, left, and then right, right? So if, and then elif event dot key equal to pygame dot k underscore down, we will do self dot turn down. Okay? And then with dot, same thing with left and right. And that is basically how we define, the turning function. So I called the turn function in handle keys just so we don't actually have to repeat the code the entire time, every time, the up arrow is pressed, and then I have to copy all that code into here. That's why I called the turn method initially and went through all of like the circumstances needed to actually be able to turn the direction over towards that the function of handling the keys. So let me make sure I didn't forget anything. I think we're okay. So I'm just gonna go over quickly what we did. This is the initial snake itself. This is getting the head position to know where we are at like the position of the grid. This is the turning mechanism. This is the actual moving mechanism. Not like changing direction, but moving the snake while you're staying in that direction, right? And then the reset function, right? Us resetting ourselves just in case the game is over. Drawing the excess part of the snake, and then handling the keys. And that right there is basically it for the snake class. We're nowhere near done with the game yet. We're going to continue this on next class because it is going to take a little bit as well. I'm just going to start off the next class by finishing the rest of this. We're going to do a little recap on this too, just so we get your memory refreshed. It would definitely take a lot longer than we expect finishing the rest of this. So I will, do the rest next class. In that case, Camille, do you have anything to add and whatnot?
No, I think that's pretty well covered. I think that's everything.
All right. So today we hope you guys enjoyed the class. We went over sort of like the basic game creation, and then we went on to like a more advanced creation so we can get, because I know there's a mixed, mixed terms of students here. Some of you guys are already familiar with Python. Some of you guys are more of like the introductory type of thing. We try to provide for both, and that's what we try to do to this class. So we decided to go with like the console games and the PyGame games. But other than that, I have nothing else to say. Camille has nothing more to say. We hope you guys have a great rest of your weekend, a great rest of your night, and we hope to see you guys next class, which will be next week, hopefully. All right. So, bye, guys.
Bye, guys. Alright, nice.
That was a good class.
Yeah, you
I
do
remember.
good. Okay, nice, nice.
All right. Catch you,
Cool.
man.
Alright, later.